Hello, Atlanta. My name is Billy KORANDO. Sounds a little. My name is Billy KORANDO. I'm a software consultant with KEYHOLE Software in Kansas City, and I'm very excited to be kicking off Spring Days Atlanta by talking about what's new in Java 9. So, before we get started, I do have a few housekeeping items. This presentation is going to run right about at 40 minutes, so I may not have any time to answer any questions during it. If you do have questions, feel free to tweet at me at Billy KORANDO, or if you see me walking around, grab me and I'll try to answer your question as best as possible. The second item is at the bottom right-hand corner of nearly every slide, I have a link to this slide deck. So it's kind of there to help with like the note-taking process. You can just write that down. You don't have to be furiously scribbling notes as I go through slides. And then finally, Java 9 is still in development. This is a bit of a safe harbor for me. So we're getting pretty close. The dev list has slowed down a lot, so there's going to be many changes. I don't think anything I'll be talking about should really change, but it's there just in case things do change. And then to that note, September 21st should be when Java 9 finally arrives. Funny enough is, last time I gave this presentation in Spring Day Chicago, it was July 27th. And about 2 hours after I left the stage is when they pushed back the release date to now September 21st. I don't think that's going to be happening. As I mentioned, the dev list has slowed down a lot. There's no more failed votes on the horizon for Java 9 items, so September 21st should be when Java 9 arrives. All right, so as I've been following Java 9, there's been a lot of misconceptions. A lot of times I kind of share those misconceptions. A few months ago, Mark Reinhold, the chief architect of Java 9, gave a really good presentation at DevOps USA, in which he kind of gave like top 10 misconceptions about Java 9, and I decided to take those top 3, kind of go through those. One of the biggest misconceptions about Java 9 is that Maven will not work, and of course, that's not true. Maven 3.0 works just fine with Java 9. And I guess a lot of these misconceptions around Java 9 is there's been a lot of concern about migrating to Java 9, that it's going to be a huge task, it's going to be a lot of work, and that's just kind of what these misconceptions are kind of trying to allay. So yes, anyways, Maven will work. Now I've heard Gradle 4.1, it also runs on Java 9. It doesn't do modularity yet, which I'll get into in a little bit. But that's what I've heard. I'm not a Gradle user myself, so I haven't actually worked with it yet. A second big misconception about Java 9 is that you'll have to modularize your code to go to it. And again, that is not true. Not only will you not have to modularize the code, Mark Reinhold himself even suggests that you should do a serious ROI before you attempt to modularize your code. It's a very labor and intensive process and also has a lot of risk involved. So you don't have to modularize the code, and you should strongly consider do ROI before you attempt it. And then the final misconception is my libraries will not work in Java 9. I'll give that one partial credit because there are some libraries that will need to be upgraded. I have found that libraries that heavily depend upon reflection, like Hibernate, AspectJ, Lombok, those are the ones I've had the most issue with, and they will have to be upgraded. So anyways, though, all this is to say that moving to Java 9 shouldn't be as big of an issue as you may have heard, perhaps on Twitter or on the blogosphere. So prove it. Let's actually take some Java 8 applications and run it in Java 9. Continue. All right, so my company, we like to talk about microservices a lot, and when we give presentations on microservices, we have our demo application, and I decided to take this application and see if I could run it in Java 9, and I felt this was a pretty good example because This is running Spring Boot, and we all use Spring Boot. It's also a little bit of an older application. I think it was built back in like early 2016, so it's actually using Spring Boot 1.3 and Spring 4.2. So I was thinking this is good because this is not exactly bleeding edge, since a lot of the applications we work on aren't necessarily bleeding edge either in our day-to-day work. So it's like, can I take this and move it to Java 9 without having to make too many changes? So of course, the first thing I need to do is, can I get it to build? And as you see, yes, we can get it to build. And there was a few things I did have to do to do that. So I think this could be a good one. And actually, I don't really need that permit illegal. So one nice change, and one of the biggest problems or difficulties initially with Java 9 was you were having to do, so Java 9 is introducing Jigsaw, and I'll get into a bit more later, but it's introducing a lot more stronger encapsulation. And a lot of things that were dependent upon reflection or just making uses of parts of the Java language that the Java architects prefer people didn't, are being encapsulated. And so you were having to open up these modules by using command line flags to get into it. And one of them is also permit illegal access. But a couple of months back, they actually set up the Java 9 to allow or to turn off this encapsulation by default, which has made the migration process a whole lot easier as you don't have to put as many command line flags. But anyways, there's a couple of command line flags I've had to add to get this to run, but it's not too many. And then all I also had to do was update the aspect J to get this to run. The aspect J it was using was 1.8, and that will not run in Java 9. You have to use 1.9 or later. But otherwise, I didn't have to make any changes to libraries. So let's actually see if these then run. And we can turn off the volume. All right, so these will boot up here. We'll give it a few seconds. That did. Okay, great. And so anyways, this microservice application is just a really simple project service application. But it is using a lot of stuff like its microservices. It's making use of the Netflix OSS. It's also using Hibernate. And it's using a few other things. So even though the actual project is relatively simple, just because of the sheer amount of libraries and then the inherent complexity around microservices, this is a reasonably complex example. That said, this is still a POC. I haven't thoroughly vetted everything, so there may be some issues, but again, migrating to Java 9 maybe isn't as much of a headache as people may have initially worried about. We'll give this a couple more moments to, let's see if it's, great, so the application boots up, and let's see if we can do anything with it. So we have Spring Days Atlanta. And since it's 2 days, we'll put 48 hours. So great, so that was updated, and our little breakdown of this pie chart, our donut chart is also updated. So, this application does seem to be working in Java 9. All right, so why get your applications to run in Java 9? So this is an upgrade with benefits. From just getting your application running into Java 9 and doing nothing else, taking advantage of none of the new features, this is what you get. You get better use of memory, better performance, better use of hardware, better documentation, prettier graphics, and faster compilation. So there is benefits just to upgrading to Java 9 and then doing nothing else, at least initially. All right, so Jigsaw. I kind of talked about it a little bit already. This is by far the biggest changes coming to Java. It's actually been coming to, this has been like a long process. I think it's been 7 or 8 years Jigsaw's been in development, and it's finally arriving. So Jigsaw is the umbrella term for introducing the concepts of modularity to the Java language, and then modularizing the JDK itself. This is a long or complex subject. It's taken me dozens of hours to kind of really wrap my head around it. Alone, a presentation on this subject could go for over 2 hours. At the end of this slide deck, I have a link to a really great presentation by Paul Baker and Sandra Mock that, again, goes a little over 2 hours. That really does cover Jigsaw well. But I'm going to spend about 10 or 15 minutes here. So if at the end of this you kind of feel like this, I apologize. It's a little bit unavoidable, but hopefully when you get to Java 9 and you kind of start having to deal with this modularity stuff, you're like, oh, yeah, automatic module or unnamed module. I kind of remember that from that presentation, and at least you may have some general idea on maybe at least on how to Google stuff. So, as I kind of mentioned, this is where also a lot of the pain from moving to Java 9 is coming from, is from Jigsaw. So like, why are the Java architects giving us all this pain? What's the benefit, what are the goals? And so there's 3 major benefits and goals of Jigsaw. The first is stronger encapsulation. When you do have a full-on modularized application and modules, you can declare its public API. Right now, public is truly public, even though you have like an implementation of an interface. You may have that be a public class, but you really don't want any clients to ever actually use that implementation. With modularity, you can actually hide that implementation in a separate package that you don't export, and then client modules cannot actually access it. So that way you can change that implementation without any concern of affecting client modules. Also, about a third of all the critical security failures can actually be kind of related back to the weak encapsulation within Java. The second big advantage or goal of Jigsaw is more reliable configuration. So modules can declare what they depend upon, and then the Java at both compile time and runtime can read in these dependencies and make sure that they are actually there, instead of just relying upon class path, which is hit or miss, which leads to things defined like class not found or class def not found. If you do have like a fully modularized application, that really should not be possible, as Java will be checking for those, like I said, at compile time and runtime. And then the final major goal of Jigsaw is to be able to create customized JDK images using the JLink tool. So Java 8, I think it weighs in at about 150 megabytes, and generally, and then like rt.jar, I think it's about 80 megabytes, but any of our applications really only make up like a very small, or make use of a very small amount of that actual code. For example, like let's say we have an API gateway. Well, your API gateway is not going to be doing anything with java.sql. So, but it still has to bring that all in to run. And this can cause, in our world of, maybe going to microservices or Internet of Things, all that additional storage space does have costs. If we're doing tens or hundreds of instances of an application, we're just having to duplicate those 10s or 20s of megabytes that we're just not even using. Or in the Internet of Things, when memory-constrained platforms or resource-constrained platforms, we're having to upgrade the storage to be able to run our applications. With the JLink tool, it can read in saying, oh, my API gateway, it's not making use of any Java SQL, and then it'll create a custom image that doesn't include Java SQL within it, so that should greatly reduce the size of the JDK image that you may be using. So that can just be where the benefit comes in massive horizontal scalability, or when storage, the cost of storage is at a premium on like devices. All right, so let's start kind of digging into the vocabulary of modularity. To help with migration, there are three different types of modules. There is an unnamed module, and so the demo I showed you earlier, that's all running as unnamed modules. And this is when you put a jar on the class path, it becomes an unnamed module. Unnamed modules export all packages. They require all modules, but they cannot be declared as a dependency. Next, we have automatic modules, and this is when a jar is placed onto the module path. The name of an automatic module is derived either from the jar name by default, so if you had like Spring Boot 1.53, that would just become the automatic module name of Spring Boot. It drops off the version number stuff. Or optionally, you can use the automatic module name in the manifest MF to give it a stable module name. That was a big debate for a while within the dev list. Like unnamed modules, automatic modules also export all packages. They also require all packages, but you can declare them as a dependency. Then lastly, we have explicit or named modules. Those terms are used interchangeably, but they're defined by the new module info.java, and they can also be declared as a dependency. One second. All right, so back in the misconceptions about Java 9, I kind of made reference to how it will be labor intensive to go to modularize your code base. So here is the current file structure. You know, we just have our source, then we have like our base package, and then we have all of our packages and code under below. When you modularize the code, well, your file structure will probably look something like this. Somewhat similar, but we'll add this new com.foo.bar folder, and then under that, we'll put module info.java. And then let's kind of look into that module info.java, and that can also kind of help explain this new file structure. Highlighted in blue are some new keywords that are being introduced for modularity. These are only reserved, though, within module info.java. So if you have a variable named module or exports or any other ones I show on here, it's not going to cause compiler error when you switch to Java 9 unless you have a class called module info.java. Anyways, at the top, we have the name of the module, com.foo.bar. Maybe best practices will actually change once modularity is actually out in the world. But right now, the best practice, or recommended practice, would be to name the module the same as the base, or the least common package name for that module, where that module exists within your project, because that way that helps guarantee uniqueness using that reverse DNS package naming strategy. And then also that folder that we added, you know, it'd be probably good to name that the same as the module name you're creating as well, just, you know, for helpful readability and simplicity. Anyways, so we're declaring the name com.foo.bar for the module name. An additional modifier could be, to this could be open, as an open module com.foo.bar. If you were to add that keyword there, that will export all the packages within this module, and then it will also allow deep reflective access into any modules that require com.foo.bar. Next down, we have the exports clauses, and this defines the module's public API. So only the com.foo.bar service and the com.foo.bar.model package within com.foo.bar are exported. Nothing else would be visible to any client modules, setting aside that you can kind of turn off a lot of this encapsulation with command line flags right now. Note that you have to export each package individually. You can't do com.foo.bar.star and then export all the sub packages below that. And the reason that is because the architects of Java wanted to make this process of exporting a public API a deliberate one that you actually thought about. So you're actually thinking about what's the public API, not just saying, oh, I just want to export everything, I'll just put a star here. Additional modifiers, you can put opens, like as in opens com.foo.bar service, and that will allow just deep reflective access to that package. You can also do opens to, as in like opens com.foo.bar.model to org.hibernate, and then only the org.hibernate module will have deep reflective access. And for example, with like module or model, you want only hibernate to be able to get deep reflective access to do all of its JPA magic. Next we have provides, just declares the services this module supports and the implementation it supports it with. And then uses, declares services this module depends upon. And so what these are kind of much more strongly enforcing dependency abstraction principles. I kind of talked earlier about like making coupling to like an implementation of an interface, and this prevents that. So if some other module depends on com.foo.bar, which I'm really tired of saying that term, it's using foo service, it would only actually have access to foo service. It could not actually make a dependency to foo service impl because I'm not exporting the service impl package, and so that can't just happen. Like you can't, and that will help prevent coupling. So if I wanted to make a change to foo service impl, or if I wanted to use an entirely different interface, I could do that without having a concern of it having some sort of unusual impact on any sort of clients. Finally, we have requires, and this is defining the modules this module depends upon. So it's requiring org.evil and java.sql. Another modifier you can put on this is transitive, as in requires transitive org.evil. So if another module was dependent upon com.foo.bar, and it also wanted to use code from within the org.evil package, it would not have to also define requires within its module declaration. It can just depend upon it getting org.evil from com.foo.bar. All right, I promise this is the last time I say com.foo.bar. So Spring Framework Java 9 support. For the current release of Spring 4.x, it will be limited and only for 4.3.10, which is due out here. I'm not quite sure, like within the next month or two when that will be released. As I showed earlier, you can run older versions of Spring in Java 9, but if you run into like a bug in 4.2, there's not going to be a bug fix for that. It's, I guess, what I would say, and I don't know exactly to what extent, you know, folks from Pivotal will actually try to help you through that issue. Spring 5, which is currently due out in September 2017, it will support Java 9, but it won't support the encapsulation principles or encapsulation concepts in it. And that's because the libraries Spring itself depends upon likely won't be supporting that encapsulation yet either. But Spring 5 will be having stable automatic module names. And then finally, Spring 6, which is maybe 2019 or later, it is intending to offer full Jigsaw support. So you can fully modularize the code. You can use all the encapsulation stuff that I was kind of showing you earlier in that module info.java. So that's the Spring core framework. For the Spring libraries, the Java 9 support's going to vary. Spring Boot 1.x, no support. Again, as I showed, you can run even 1.3 in Java 9, but if you run into some sort of bug, you know, 1.3 or even 1.5, from the looks of it, those will not be fixed. Spring.2, which last I checked is due out in November. It is going to support running in Java 9. So if you do run into bugs, you know, you can tell them about it and they will fix them. And then the other libraries will vary as to their when and what versions they'll start supporting Java 9 in. All right, so that's it about Jigsaw. So let's get into the other features of Java 9. One of my favorite is JShell. JShell is a command line shell, or is a REPL. If you're not familiar with the term, that stands for read, evaluate, print, loop. And what that means is that it's a command line shell that will read in a Java expression, evaluate it, print out the result of that expression, and then loop it back to the command prompts. REPLs are used to explore APIs and also as a tool to teach Java language, or to teach programming, in this case, of course, Java. And I'll focus on the second part of that tool to teach Java, which might sound a bit strange when talking to a room full of experienced Java developers. However, I think many of us want to remain in the Java ecosystem, and the only way that ecosystem is going to continue to grow and thrive is if we have more students coming in, or more new developers coming in from schools. And schools and universities were the ones that are kind of really pushing for a REPL to be implemented in Java, because other languages like JavaScript and Ruby had those. And so schools were kind of turning to them to teach programming to. So let's understand why this is useful. So here is the most basic Hello World program. And so our seasoned eyes, you know, this is a pretty simple program, but to somebody who's never programmed before, this can be quite complex. What does public mean? What's a class? What is static? What is void doing here? What is a system? Why are the semicolon here? What are these brackets doing? An instructor overwhelmed by all these questions might say, don't worry, we'll get to them later, but it does raise a question as to how do you introduce these concepts in a fashion that students can understand without getting so lost. Let's take a quick demo of Java 9, or JShell then. Let me go and quit all of these. Is that large enough for everybody? Great. All right, so to fire up JShell, you just type in JShell, and a quick tutorial on JShell itself. To actually talk to JShell, you have to prefix with a backslash, and if you do like backslash help, that will kind of show you all the other different commands that JShell offers. So, first program we ever write in a language is Hello World, so let's do that in JShell. And that's just simply doing Hello World. And then, great, we get this printed back out to the console, Hello World. In JShell, for just single line arguments or expressions, you don't have to do a semicolon at the end, it just prefixes that automatically. Also, you'll see that $1, that's called a pseudo variable in JShell. So when you just kind of like type in what's a variable looking like thing into JShell, it'll automatically assign that to a pseudo variable. And so if I type in $1, that will then bring up that variable name. So Hello World, we just already implemented that in JShell. The second program many students write is taking some sort of user input and then printing that out. So let's do that in JShell. So we will do void print hello string arg, and then we'll do system.out print line. And so now, since I'm doing a multi-line expression, I do have to follow the full Java syntax, so I do have to end a line with a semicolon, and there. So I can just then do, JShell offers tab completion, so I have like PRI, tab. It shows us different options. Because PRI, there's print hello, that's the only option, it automatically just does that for me. And then great, we get hello Atlanta. So hello world, hello taking some sort of, or using some sort of user input. The next thing is working with like different variable types or primitive types. So let's just do int x, int r, and then double y. So if we were to do x equals 5 divided by 2, we get 2. If we do y equals 5 divided by 2, we get 2.0, but you know, we're still getting 2 because we're doing integer math, and so Java is just dropping that remainder. If we were to do y equals 5.0 divided by 2, we get 2.5, and then we did 5, x equals 5.0 divided by 2. We get an error, incompatible types, possible loss conversion, and of course that's because x is an integer and it doesn't have floating point, so that gives an error. But this is shows just how quickly and how easily it is to demonstrate different programming concepts to students. I mean, how difficult, would it have been for students to write out a program that does something like this? People new to programming would be running into like compilers because they forgot like a semicolon or a curly brace. This is just a much quicker way to introduce concepts in a much smaller format so students can learn them easier without having to worry so much about all the Java syntax. So that is JShell in action. All right, so let's get through some of these other features. We're kind of running on time. Collection factory methods. I think this will have a lot of benefit when it comes to unit testing. If a method you're testing takes in some sort of collection, it can be a lot of work just to set up like a collection to test with. Here we're doing like a list of strings and list, new array list, and then list.add, I mean, just for strings, it's a lot of work. So now they've introduced list.of for collections, so we can do list of, and then how much less syntax or how much typing is needed to be done is quite evident there. We can just put in our arguments. They also have this for maps. So this map.of will only work for up to 10 items in a map, and it of course has to follow the key value. So like I have an integer and string. So if I was to put two strings next to one another, that would give an error. But this will only work for up to 10 items. If you need to add more than 10 items and you want to use like a sort of syntax, there's also map.of entries, and you can do map.entry, and you can pretty much add as many as you want. Stream updates. So streams are added in Java 8, and they were met with like a lot of success and praise. But one problem with streams in Java 8 is they don't work well with really large streams or infinite streams. So to that end, take while and drop while are added, and so those will work. So take while will take items out of a stream as long as the predicate is true, and then the inverse of drop while will drop items out of a stream as long as the predicate is true or is false. So that's added. That's a help if you're using with really large streams. Private interface methods, another thing that was added in Java 8 was default and static methods for interfaces. And so now if you have multiple default or static methods within an interface and they are using some of the same code, you can now put that into a private interface method to not have to help with your usability. Try with resources, that was added in Java 7 to automatically close a resource without having to use use a finally block. Before we had to declare the resource within the try block or within the try declaration. Now, as long as a resource is effectively final, for example, within as a local variable within a method or as a final variable within a class, you can declare before and then use it in the try block. There is multi-release jars. For library, this may not be super relevant for if you're just an application developer, but for library developers like people from Pivotal, this can be very beneficial. If you are making use of a library that has to use large streams and you want to take advantage of that new take while and drop while without having to wait for everybody to upgrade to Java 9, multi-release jars are for you. So within the manifest MF of a jar, you would add the new value multi-release true, and then that will tell the JDK to then read in these version folders. So if you're running in Java 9, the foo and bar class under the 9 folder would be overwritten the foo.bar class up in jar. If you're running in Java 10, it will bring in the foo class from 9, and then a bar class from 10, and it would still be using that original evil class. But this is a way for to be able to take advantage of maybe newer features in a newer release of Java, but still being able to have backward compatibility. And this is also fully backward compatible. If you were to run this jar in Java 8, it wouldn't even know what to do with this multi-release true, so it would just ignore it. We finally made it to the most important part of the presentation, documentation. So there is some Java doc enhancements. They're now searchable, and they are also HTML5 compliant, and also deprecated, has been enhanced with for removal and sent, and we can just take a quick look at that. So up here we can search, so we can just do like for our employee repository, all that, but you can see how it's also bringing up like the employee model and employee entity listener. And then here we also have the deprecated enhancements and the for removal, so it's going to be removed at some point, and the since, that can be an arbitrary string. In this case, I had a date, but you can do like since, version 1.2. Some additional changes. There's reactive updates. I just did not have time to get into that in this presentation. G1 is the new default compiler, default garbage collector. It's available in Java 8, but now it's going to be a default in Java 9. And one of the really nice things about it is it offers string deduplication. So let's say you have two variables that are both have the string value of hello world. G1 will remove one of those and then have both of those variables point to the same string memory address. Compact strings, so in Java 8 and before, strings are backed by a char array. Now they're going to be backed by a byte array. The API is not changing, but it should save memory. Strings take up, like one of the Java architects wrote, noticed like they take up the most memory within a JVM. So these two changes would have some pretty good impacts in memory heap usage. A new version format. So the current versions version format for Java is kind of opaque. Like, I don't really understand it. The new version is a lot more straightforward. It does major, minor, security, and patch. One thing to keep in mind though with security is within major versions, that will always remain the same through like different minors. So if you have like 9.0.10.2 and then 9.1.5.2, the first one, the 9.0, will have more recent security patches in it than the 9.1. So that's, like I said, the security is not going to roll over with minor versions. So that's just something to keep in mind. There's also HTTP2 support, but it's experimental, so that could change in JDK 10 or later. So if you are going to make use of HTTP2 support, I would recommend finding some sort of wrapper or something to hide some of the details, so that way if you do upgrade to Java 10, it's not going to be so painful when you do. Unified garbage collection logging, unified JVM logging, and stack walking API. Removals, JHAT, God help you, you're still using applets, internal APIs, deprecated garbage collection combinations, the hprof agent, developer tools. IntelliJ, they already have full-on prod support for Java 9. That started in 2017.1. I think they're up to .3 or .4 now, and they're still taking in feedback on how to improve upon that. Eclipse, that's currently in beta, but requires the Oxygen release of Eclipse. That means that's available nightly builds. As I mentioned, Maven 3.0 works with Java 9, and Gradle 4.1, it runs in Java 9, but no module support. If you want to follow people for Java 9 news, these are really great resources. The first two really talk about Jigsaw. Nikolai Parlog, he talks just a lot about generally about Java among other, or Java 9 among other Java topics. And then here's some resources. So the first one, for the demo I showed earlier, that's where the source code's located. And these are all some really great talks and articles on Java 9. And the last thing is finally get started. Here are the links to Java 9, the early accesses. Thank you very much.